Today's lesson comes from section 11.1. It's on simplifying radical expressions. There's 4 main steps that you want to do while you're simplifying radical expressions. The first thing is that you want to make a factor tree. Next, you're going to look for pairs to pull out. Then you're going to multiply all numbers and variables outside the radical. And lastly, you're going to multiply all numbers and variables left inside the radical. So we'll start with some level 1 problems, the easier simplifying problems. Let's start by breaking down the square root of 48. So I'm going to make a factor tree for 48, which means I'm going to ask myself what numbers multiply to be 48. And the first 2 numbers that come to my mind are 2 and 24. These might not be the numbers for you, but either way, it'll end up working out. So then I go ahead and I'm going to cross off 48 because I've already broke it down, and I'm going to ask myself, can 2 be broken down further? And the answer is no, because it's prime. So then I look at 24 and I say, can 24 be broken down further? And it can. And so the 2 numbers that come to my head are 3 and 8. That might not be the same for you, and that's okay, because your factor tree should end up looking the same regardless. So then I ask myself, is 3 prime? Yep. So I don't break that one down further. Is 8 prime? Nope. So it needs to be broken down further. 8 can be broken down into 4 and 2. And I'm going to cross off the 8. And then 4 can be broken down into 2 and 2. And now, if I look at the stems of my factor tree, I should have 1, 2, 3, 4 2s and a 3. And regardless of what numbers you pick to break down in the beginning from 48 or how you decide to do it all the way along, you should have the exact same stems at the bottom. So now I'm going to look at those numbers and I'm going to look for pairs in those numbers. So when I teach this in class, I like to say that I'm looking for numbers that are going to go out on a date. So if you're going to go out on a date with somebody, you're going to look for someone who is similar to you, that you like their qualities. So when I'm looking for pairs, I'm looking for matches. So in this case, I see that I have a 2 and I have another 2. So I'm going to put half hearts around them and I'm going to say that they're in love. And I'm going to go ahead and I'm going to say they're going out on a date. Now when those pairs of 2s go out on a date, they're only going to need 1 table for both of them. So outside of the radical, I'm going to write 1, 2 for both of those 2s. Then I look and I see another pair of 2s. So we have another couple that can be made out of this group here. And when they go out on a date, they will also need 1 table for the 2 of them. So I'm going to write 1, 2 for both of those 2s. And then I look and all of my numbers that had pairs are paired up. They're out on dates. And I look at this poor lonely little 3. He is the only stem left and he's got no partner, so he doesn't have anybody to go on a date with, which means that he is going to stay home underneath the radical. So I'm going to write my radical and I'm going to write a 3 underneath. My next step says that I'm going to multiply all numbers and variables outside the radical. So I've paired up everything, I've pulled everything that I can out, all of my stems are used, and now I want to go ahead and see what I'm going to do with those numbers. So I'm going to multiply the 2 by the 2, because those are 2 numbers outside the radical. And when I do that, I get 2 times 2 is 4. And then there's nothing left underneath the radical other than 3. So I'm just going to write radical 3. And my final answer is that the square root of 48 equals 4 radical 3. Now let's try that again with another type of problem. So let's try breaking down the square root of 72. So if I try breaking down 72, example 2 here, the first 2 numbers that come to my mind are 2 and 36. Those might not be the same for you, but that's okay. And then 36 can be broken down into, let's say, 9 and 4. And I'm going to cross off the 36. The 9 can be broken down into 3 and 3. And the 9 is done. And then the 4 can be broken down into 2 and 2. And the 4 is done. So now I look at my stems, and at the stem I should have 1, 2, 3 2s and 2 3s. And so I'm going to go ahead and I'm going to ask myself, are there any pairs? And there are. There's a pair of 3s right here. Those 3s are in love, so I'm going to write them outside the radical 1 time. So 1, 3 for the pair of 3s. And then I have a pair of 2s right here, and those 2s are in love, so I'm going to write 1, 2 outside of the radical for that pair of 2s. And then last but not least, I have this 2 here, and he's all by himself. He's got nobody to go out on a date with, so I'm going to go ahead and write him underneath the radical all by himself. He's staying home tonight. And then my next step I look at, it says that I'm going to multiply all numbers outside the radical. So I'm going to take that 3 and that 2 and I'm going to multiply them. So 3 times 2 is 6. and then there's only the 2 underneath the radical, so my final answer is 6 radical 2. Those are your basic level problems. Now we're going to go ahead and get into example set 2, where we add some variables. So I'm going to scroll down here, and example set 2 with variables. Okay, variables you're going to treat the exact same way as the numbers. You're going to still look for pairs, and you're going to pull out those pairs. You're going to multiply them just the same way. So let's go ahead and let's try breaking down the square root of 52 x to the 26th. Okay, so this is problem number 3. And we'll start by breaking down the numbers because we already know how to do that. So let's go ahead and break down 52. 52 can be broken down into 2 and 26. 26 can be broken down into 2 and 13. And then 2, 2, and 13 are all prime, so I'm done breaking down my numbers. I'm going to look for my pairs, and I have a pair of 2's. I'm going to write that pair of 2's once outside the radical. And then this poor 13 is left home alone underneath the radical. And now I'm going to switch over to my variables. And with variables, I am doing the exact same thing with the numbers. I can break it down and make a factor tree. Now, if I have x to the 26th power, that means I'm technically multiplying x out 26 times by itself. So I could write out 26 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. And yes, it can be tedious. Once we start pairing these up, you might see a pattern. So check and see if you notice anything special about this. I wrote out 26 x's, and I'm looking for pairs of x's now. So I'm going to circle all the pairs. I have 1 pair, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So I have 13 pairs of x's, which means that I'm going to have 13 x's that I can pull outside of the radical. So I'm going to write x to the 13th. And if you notice anything special about this, 13 is actually half of 26. Now that's because you're taking the square root, so you're looking for pairs of x's. So you take 26 and divide it by 2 and you get 13. Okay, so my final answer is that I have 2x to the 13th times the square root of 13. And I am finished with that problem. Alright, let's try another one. So let's try doing one with an odd exponent. So let's go ahead and do the square root of 64 b to the 19th. We can start by breaking down 64, or what I would suggest that you recognize is that 64 is a perfect square, and the square root of 64 is 8. So we don't even have to break down 64 at all. We just know that the square root of 64 is 8. So I'm going to go right to saying 8 is outside the radical. And then I'm going to write my radical, and I'm going to figure out what's going to happen with these b's. So if I wrote out 19 b's, I would actually end up with 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs of b's that can be taken out, and then I notice I have 1 lonely b that's left at home. So anytime that I have an odd exponent and I'm taking the square root of it, I'm going to actually always end up with 1 left over, because there will always be 1 left over when I divide that number by 2. So my trick for doing these is that I take the exponent, so I take 19 in this case. I'm going to subtract 1 from it because I know that there's going to be 1 variable left over inside the radical. And so I end up with 18. Then I divide that number by 2 to figure out how many pairs will actually be outside of my radical. So I end up with 8b to the 9th times the square root of b. Alright, let's go ahead and try one more set. And this is the hardest set of them all, because we are going to be doing a lot of stuff inside and a lot of stuff outside, and then we're going to be multiplying it all together. So we're going to get all of our steps in here. So, example set 3. We'll call this the challenging level. So, Let's go ahead and let's start with 2x radical 50x cubed. Okay, notice there's numbers outside the radical already. So when we go ahead and break down our numbers and our variables, we're going to have to be multiplying those with the numbers already outside. So let's go ahead and start by breaking down 50. 50 breaks down into 2 and 25. 25 breaks down into 5 and 5. And I look and I notice that I have a pair of 5s. So I'm going to take that pair and I'm going to pull it out outside the radical. So I already had 2 and x outside the radical. Now I have 5 outside the radical. And left at home, I'm noticing from my numbers, I have a 2. And then I'm going to look at that variable, x cubed, and I'm going to take 3 and I'm going to subtract 1 from it because I know that there's going to be one variable left over underneath the radical because it's an odd exponent. So I get 2. And if I divide that exponent of 2 by 2, I get 1. So that means I'm going to take 1x and pull that outside of the radical. If you wanted to, you could still draw out all the x's. So you could have written out 3 x's to break down that radical. So x cubed is x times x times x. And you notice that there's one pair of x's, so you're going to write those outside. And then there's one x left at home because there's one x that's not paired up. So then you'll write him inside. Okay, and then if we look at our properties or rules from the beginning, so we looked for our pairs to pull out. Now we're going to multiply all the numbers outside the radical, and we're going to multiply all the numbers and variables inside the radical. So looking at this one, we are going to take 2x times 5x, and we get 10x squared. And then inside the radical, we have 2 times x, which is 2x. So our final answer is 10x squared radical 2x. Alright, one more, and then I'm going to give you three problems to try on your own, and we'll be done with homework for today. So last example, let's try 2b squared radical 75b cubed. So let's break down 75. Breaks down into 3 and 25. 25 breaks down into 5 and 5. And there's a pair of 5s, so I'm going to take those, I'm going to pull them out. There's already 2b squared, so I'm going to write that outside automatically. Then I'm going to write the 5 outside. I'm going to make my radical, and there's a 3 left at home because he had no pairs. And then I can either write out 3 b's and pair them up and pull them out. So here's a pair of b's. So I write 1 b outside the radical, and then there's 1 b left at home. Or I could go ahead and do the property where I say, okay, 3 is an odd exponent, so I'm going to subtract 1 for my 1 radical that's going to go stay at home, my 1b that's going to stay at home. And then I'm going to take that exponent of 2 and divide it by 2 to see how many pairs of b's will I get outside of my radical, and in this case it's on 1. And then last but not least, I go ahead and multiply everything outside the radical. So 2b squared times 5b gives me 10b cubed. And I multiply everything inside the radical, so 3 times b is 3b. And my final answer is 10b cubed times radical 3b. Now I want you guys to go ahead and finish. I'm going to do one problem of each type. So let's start with radical 60. And your second one will be from level 2. Let's go ahead and do the square root of 125 x cubed. And then finally, let's go ahead and do, let's do negative 3 radical 72 x to the 4th as your last one. So try those 3, and then you're finished with your homework for tonight.